I'm by no means an AI expert, but I've had a lot of experience with data provenance because I've been building decentralized data protocols. And so today, I'll basically be talking about sort of my observations over the years and sort of how I think these two things intersect. So I wanted to start talking about sort of the problem of AI, like the risks ahead. And it seems like we're in this path, and there's basically two paths that both are kind of bad. So in one scenario, we go into a world there's centralized controls, someone controls all the AIs, there's no privacy, there's censorship, and I can sort of do what they want. And the risky thing here, I guess, like it also is like a winner-takes-all scenario, but this is not really like a future we want. And the other side, which I think the side that like many of us here probably are thinking is the right side, is like the decentralized AI, like everything, all the capabilities of AIs at the edges. And this is sort of nice if we think about it from like a self-sovereign perspective, but it actually brings a lot of risks. So deepfakes is one thing, but even beyond that, like if you can just use an AI to create sort of drugs or like very dangerous weapons, it's a real problem. And so we need to actually have some way of having alignment, which is not only aligning the AIs to humans, but actually aligning humans all across the world to like not everyone compete for this winner-takes-all centralized control scenario. So I wanted to start talking about trust. So if you think about this deepfake problem, there's a few different approaches that are being approached. The main one is being by a consortium of companies called Content Authenticity Initiative. And this is basically like a few companies coming together to sort of verify content online. And basically what it is signatures, hashing, and timestamping. And funnily enough, is stuff that like the crypto community is actually really good at. But what this looks like in practice is that you snap a photo with your camera. So maybe you have a Canon camera. That camera has a key on it that signs the content. And that key has a certificate from Canon, the company. Then you edit this photo in Photoshop, and Photoshop sort of signs that edit. And so you can have this like flow of all the edits that happen to a photo. And this is nice, right? We can, if the website supports it, we can actually look at all the things that happen in the edits, and we can know like, oh, this is definitely not a deepfake. There's sort of like two problems with this. The first one is that someone might not just use this and just upload a random picture without any metadata, and we have no way of knowing if it's like real or if it's a fake one. The other problem is that now we have these like big companies that all control what is like true, right? And we can imagine some entity maybe wanting to put pressure on all these companies to like censor some particular happening in the world. So like all the photos coming from that particular place actually is like now considered false. So there's like two problems with that. The other approach to this problem is something called perceptual hashing, which is basically taking a neural net, an AI tool, and looking at an image, generating sort of a hash that represents the picture. And you can have two different pictures that are like slightly edited, and you can get the same hash. So this is nice, and I think there's more to be explored here. But it sort of has problems that sort of neural net things have in general, which is that they can be easy to fake. And so there are some like problems like actually making this really robust. But even beyond these two approaches that I talked about, they really only apply to like images, audio, video, maybe like written content, but it doesn't really work when it comes to like the stuff we get with jailbreaking model and like generating like really harmful content. So imagine someone is using a model to generate like a recipe for how to make some drug or how to make some kind of harmful weapon. That we really don't have a problem, or we don't really have a solution for this problem, except like the centralized control where someone sort of surveils everything and looks at what everyone is doing. And like the one key thing to realize here is that like if there's someone that is not mentally well, they might actually get access to a model like this and do something like this. And so we actually need, in order to solve this problem in a way which is not like authoritarian and surveillance state, we need some sort of web of trust. We need to have communities and peer accountability in like actually small groups of people. And that needs to scale up to multiple layers up until like the entire planet. And so this is a really big challenge, and I think the Web3 community actually has the tools to be able to get at solving this problem. I think also if we have like a web of trust like this, it can serve as like a basis for something like quadratic voting and funding, which is a really good way of like thinking about more digital democracy. But how can we make this web of trust? Web of trust has been this like term that's been around for a very long time, and it never really like worked, never really took off. I'm sure a lot of people here, since it's sort of a Web3 conference, you've used Signal, but how many of us actually like go and verify all of our contacts that like actually verify each other's keys? It's just like a social interaction that is like has a lot of friction. So in order to make web of trust work, I think we need to make web of trust implicit in everything we do, all the actions that we do online and in sort of digital environments. So ideally, we can end up in a place where we can go to like an ether scan of data, and we can just look up any action that was taken and see that like, yeah, it's valid, and it was taken by this person that's like one hop. Basically, my friend knows them. But there's a problem with this, of course. It's like, if it's a downvote, should that be like treated the same way in terms of trust as a very good positive review? Well, obviously not, right? So how do we deal with that? We basically need some way for the computers to understand what's going on. And so there's actually been a long-standing effort to do this called the semantic web. For those who know it, it's kind of funny. The semantic web was the thing that was called Web3 before Web3 existed. So this effort by W3C to create a standard called JSON-LD to make the web machine readable. But JSON-LD never really took off. It's like burdensome for developers to implement it. But the nice thing now is that we have LLMs, and LLMs sort of solve this problem of making the web interpretable by machines. And we can create something called vector embeddings. And vector embeddings is basically pointing your model at a piece of content, like a website or a PDF or something like that, generating something called a vector that basically represents this content in a way that the AI model understands. And then we can create an index of this. So if I search the web, I can get results based on content. And if we can do this in a way where like all the content that individuals creates have embeddings, we can actually search sort of more in a more like human way with content. So I can say like, is this person over here, reputable when it comes to biochemistry? And I can get back a sort of written human language result, but I also have references to cryptographically signed sort of attestations from my friends, and like this hops to like make me trust that statement. And so this is pretty cool. Can we just like embed everything on the internet and have combining this with like the signatures we talked about before? We kind of can, but the main problem is just like, how do we trust the vector embeddings? If I have a piece of content, how do I know that this embedding this vector actually is accurate? Someone could create like a fake vector for a piece of content to put it in the wrong place. Basically, the way we would solve this would be to have these embeddings signed by people who actually run the model. So people who are running these like big closed models like OpenAI, Google, and so on, actually can you sign the outputs that they give us and assign the embeddings that we generate using these models. So that sort of solves the problem. Unfortunately, like it puts a lot of trust in these like big AI companies. Ideally, we could do something like making a zero knowledge proof of an embedding that is using one of these like open models like Mistral or the smaller Llama model. I think in theory this is possible. It's probably like really hard in practice right now. Okay, so great. We have all the internet as embeddings. Everyone has signed everything. This sounds pretty terrible for privacy, right? Like we're not really that much better than the world where there's a centralized entity that's just like monitoring everything. So what do we do about that? Well, I think, first of all, we should just realize that in general, it seems like right now, AI is pretty bad for privacy. Everything we do basically involves talking to some company that gets all of our data, and in order to run these like inferences and give us like these really useful interactions that we get from AI. So in the Web3 space, there's been a bunch of talk about something called a data backpack, which is basically this idea that you put on a backpack, you put all your data in it, and you go around to different services, and essentially like give those services pieces of your data and selectively disclose them. This seems like reasonable, but unfortunately, in the world of like an AI where we want as much relevance as possible, we're likely going to end up walking around with an open backpack where like all the services that we use just get access to all of our data. So it's not really like a great solution. And so I think what we really need to do instead is, instead of users taking their data to the applications that they use, we need applications to come to the users and use the data locally with the user. So we need to return to a world where we download the application and we run it locally on device. Otherwise, there's no way we will have privacy in the future. But we can do this, and we can also have social spaces between users where we have privacy globally, but we have like sort of sharing data and sharing our vector embeddings between people. And I think one of the cool things about LLMs is that we can actually use these tools to generate the applications that we need for the moment. So if I need a very specific way to like edit an image or edit a spreadsheet, I can just ask the AI model to generate that tool, and now I have it locally. Maybe no one else have it, but I can share it with them if they need it, and we can collaborate on that piece of data. All right, so I wanted to talk about a little bit of sort of few promising projects that are moving towards this direction. So first of all, Gitcoin Passport. They're basically building the fundamental building block of the Web of Trust. They allow you to basically verify your identity against like a bunch of different services, and then use that as a basis for a Sybil resistance score. And you can use this in Gitcoin, of course, to do quadratic funding, but I think it can be used for so much more, especially if they start doing more sort of privacy-preserving parts of your passport that you can use selectively disclose to different people. Index Network is another project that is taking it upon themselves to sort of start building this global vector index of data on the internet, and started sort of doing that indexing. But I think what's really cool about Index Network is they have this feature that allows you to not subscribe to a channel, not follow people, but you can subscribe to a semantic search. So basically what that means is like I can go to like the application and say, hey, I want to know about all new hat tricks that happen in football anywhere globally. And I'll get sort of a data feed of like all of that happens when those sort of games happen, right? So that's pretty cool. Coordination Network and DeSci Labs are building sort of tools for decentralized science. So I think science can be like a really cool first use case for this type of Web of Trust, where in some cases, DeSci Labs, for example, is doing a decentralized peer review system. And so that's like really tangible of this like Web of Trust thing. Powerhouse is doing something similar, but mostly for DAOs. And so and Coordination Network is cool because it actually starts to allow you to customize prompts for different things and share those between users. So we can have this like on-the-fly generation of applications that are sort of moving in that direction. And so why am I talking about these projects in particular? Well, the thing they have in common is that they're all built on the project that I'm working on, which is Ceramic. So the main thing that Ceramic provides that makes all this sort of easy is that is mutable objects. And so these objects are version controlled. They're tamper resistant, so timestamped on chain, and they're signed cryptographically by end users, so with cryptographic access control. And the nice thing is these objects are independently verifiable. So I don't need to synchronize the state of the entire network to know the state of one object. I can download one object, keep it locally on my computer, and verify that independently without necessarily even revealing it to other people. And this is all in a global namespace. So all data on Ceramic is addressed with a cryptographic identifier, and each node can sort of select which part of the network that they share data to. OK, so what about privacy? Well, right now, all data on Ceramic is written in public, and other nodes can synchronize it. One of our key focuses right now is building a physical access control layer, which means that I can select who is allowed to synchronize data from my node, and the data doesn't actually physically move around the network unless I allow it to do so. And with this, we want to push data out towards the edges so that users can hold their data without sending it around, and any type of like company or other entity can just like hold the data and share it with whom they would please. All right, so based on sort of what we talked about so far, like what is really missing in the space of like data provenance and sort of the intersection with AI? I think we need better tools for community formation. And what this means is like this web of trust only really works if we can have some way of like determining what are the different communities and how do they interact. This is also like really important for things like quadratic funding and voting and so on. And so we need just like better tooling for creating communities. I think one thing that's really cool that comes out of the complex systems science realm is something called community detection algorithms. So this is actually like a branch of like research. So basically algorithms that you run over social networks to determine like what are the different communities in these social networks and sort of what are their relationship. More tools that use like quadratic voting and signaling. I think in particular it would be interesting to see sort of using quadratic curation to curate like an RLHF dataset that we can use to sort of have a more democratically trained AI. Finally, we need better ways of sort of having accountability between peers and in communities. And this needs to be at all scales, like small groups of people and friends, larger communities, nation state size, and like ultimately globally. And one key takeaway that has like is really impactful to think about, at least for me, is that in this world of like AI that's just like more and more advanced, the health of local communities is actually a critical requirement for us to have security globally. And so what I mean by that, well, basically, if there is like a community that has like a bunch of unhealthy, like mentally unhealthy people, they get access to the massively powerful AI tools and can you see like, oh, I just want to destroy the world, and they just like go and figure out how to create some sort of bioweapon or something like this. That actually is like global risk. And so it's actually critical that our local communities are healthy so that we can have security globally. And I hope that with these tools that we've been building for years in the Web3 space, we can actually help to address these issues. All right, thank you.
Thank you, Joel. We have time for just one question. Over here.
Yeah, I'm sorry, it's not really a question. I just wanted to congratulate on your last sentence. I think you're absolutely right. The only thing that a rogue AI could not attack is actually small communities, because that's where we can filter for AI. All other stuff we cannot filter for AI, and that's where we cannot defend. So yeah, that's probably the key to AI safety.
Yeah, it's really scary, but it's also like sort of, I want to live in the world where we solve that problem, because that seems really nice.
Thank you so much, Joel, for your talk. Round of applause for Joel.